Hello, and welcome to my tutorial series on how to use C# in Unity. In this video, we will be going over different types of variables and how to use them. Let's begin. So the very first thing we're going to do is we're going to go over and open up the C# script that we were using last time. And I'm going to get rid of these two lines right here because we're not going to be using them today. And I'm going to take a second and talk about data. Data is very important in games or just in software in general. In games or in software, we oftentimes take data, such as in a game in a player's health, the player's position, how many coins you collect, how many bullets are left in your gun. This is all data we have that we want to store somewhere, and we always store it in memory. So the way we store data in memory is in a variable. For lack of a better way of describing, a variable is almost like a container to put our data in. So the very first variable we're going to talk about is int. And int basically stands for integer, and it's any whole number or any number that does not have a decimal in it, such as 1, 2, 3, and it also can be negative numbers, -1, -2, and so on and so forth. So whenever you create a variable, you have to give your variable a name. So let's just call this one number. You can make this, you can name this anything you want. You can call it Fred, you can call it Harry, you can call it Dandelion, but it's a good idea to name your variable in context of what you're using it for. That way other people can understand what it's used for. So you name your variable and then you set it equal to the number you'd like. In this case, I'm just going to put it as the number 1. So I said that variables are used to store data, and each individual variable has a certain amount of data it can hold. In the case of int, it can hold 4 bytes of data. And you might be saying, well, how much is 4 bytes of data? So I'm not going to get too deep into the subject of binary math or bits and bytes, but there are 8 bits in each byte. So in int, there are 32 bits of data. And you're probably still wondering, well, what does that mean? So basically, is that the computer understands ones and zeros. So that's 2. So once again, I'm not going to get too far into binary math, but what I mean by 32 bits of data, one of those bits is used for the sign because it could be negative or positive, leaving us with 32 other bits. So I'm going to take 2 to the power of 31, and I'm going to get a little over 2.1 billion. So that's the maximum number that you can have or store in any individual any individual int. So, and you can see that right here if I click on int and I go to peak definition, it's going to tell me that the max value of the int is the number that was just on the calculator. It's a positive 2.1 billion, roughly. Or it can go to, its minimum value can be a negative 2.1 some odd billion. So I'm going to X out of this. And just to show you another thing is that you can actually get rid of the sign if you'd like. If you say, well, I want more than 2.1 billion in my int, and I'm using a positive number, I don't need that negative number because it's split in 2. If you put a U in front of it, it becomes an unsigned int. So now, if I go to the peak definition, it will tell me that my minimum value can be 0, and it's going to double my max value from the 2.1 in either negative or positive direction and make it into 4.2 billion. So let's go ahead and close this out. And I'm just going to get rid of the U right here for no particular reason. And I have this int now, it's called number, and I've assigned it the number 1. However, let's say in a different location, I want to use a different number, but I don't necessarily want to change it up here because maybe at some other point, I might want to make this number something else. So let's go over here in our start function and let's type number equals 3. And then what I'm going to do is I'm going to write debug.log, and then I'm going to put a parentheses, and inside it, I'm going to put the word number. Now what I've done here in the start function is that even though it's 1 here, I've reassigned it to the number 3, and when I hit start, it's going to put the number 3 in the debug log. Let me hit save so it can compile. And right here in the Unity editor, it's going to put the number 3. So I'm going to hit play, and boom, it printed the number 3. Another thing you can do, or play around with, is that actually you can do mathematical operations with your number. So I can say that, for example, I can multiply it by 2, hit save, go into the editor, let it compile, hit play, and it'll tell me now that the number is 6. So now that we've covered integers, let's cover some of the other data types. So an integer, we can only use a whole number. We can't use a decimal number. If I were to type 1.5 here and hit save and go back into the compiler, it's going to give me an error. It's going to say cannot implicitly convert type double to int. And there's the next thing we're going to talk about, double. So I'm going to go back into the script and I'm going to take away our 0.5 there, hit save, and in the same convention, I created my int. I'm going to create a double, and I'm just going to call it number 2. And I'm going to set it equal to 5.5. Now, the first thing you have to know about the double is that this is 4 bytes, and this is 8 bytes. So now I can hit save, and I can go in here, and my error should go away. And it's going to tell me it's not assigned to anything because I didn't do anything with it. So let's go ahead, and I said 5.5. So let's go here and put number 2 there. And let's get rid of this. We're not going to use it for anything right now. So now I have number 2 there, which is my double, and I'm going to multiply it by 2. And I'm going to hit save to that. I'm going to go back into Unity. Now I've got it assigned, so it should take that away. Okay, that's my first number it's complaining about because I didn't assign it to anything. And then it's going to 5.5 times 2 is 11. So let's shut that off. So going back in here, let's talk about another type of number you can create into a decimal. And that's called a float. And actually, I'll just shorten this out to num. Since I'll be typing a lot, why create a long number? There we go. So anyway, now I got this float. I called it num3, and we're going to say it's equal to 5.5 like the other one. Actually, let's change it up so we can see the difference. Let's just make that 3.2. Whatever. So anyway, I created a double, and I can make that a decimal, and I can create it a float. But if I go over here, it says it's a double. And actually, when you're creating a float and you want to use it as a decimal, you actually have to put an F on it. And I'm going to hit save right here, and it's going to get mad at me, and then the computer is actually going to tell me that. It's going to say literal of type double cannot be implicitly converted to type float. Use an F suffix to create a literal of this type. So going back here is that this will be considered a double until I put this F behind it. And I really wish I had a very good reason as to why this happens. I believe it has to do something with .NET and not really something in Unity. But if you don't put this F here, it will consider it a double, and it won't like it. It'll tell you I can't convert this to a decimal like this. So if I actually put this here now, and I call that num3, and I hit save, we should be able to get rid of our error. Let's just clear this out so it looks less messy. I'm going to hit play, and there's 6.4. That's our number times 2. So you might be asking yourself, why would I bother to use a float at all? Why wouldn't I just use a double all the time and not have to bother with this F? And the reason is to what we were talking about before about data and storage. A double is 8 bytes and a float is 4 bytes. And it might not mean a lot when you're making smaller games, but when you're making bigger games and bigger projects, you definitely want to be cognizant or aware of how much storage you're using up. So the idea is that if you don't really need a double and you don't need to set aside 8 bytes of storage, then you shouldn't. You should just use a float and just use the 4 bytes of storage. So the last variable we're going to talk about are strings. The first thing I'm going to do is I'm just going to get rid of all this. And a string is a set of words. And let's say, let me type this out first. Let's call it strings. Let's just call this my words and set it equal to, and let's make a sentence. This is my C# tutorial. Go to the end, put a semicolon. So a string has the same convention as the integers and floats, where I'm going to put the keyword here, string. I'm going to give it a name, and I'm going to set it equal to a bunch of words or sentence that I'm going to put here in quotation marks. That's here in red. And I'm going to put it right here in the debug log. And you're saying, well, why would I do that? Why wouldn't I just type this here? And, this sentence isn't so big or, anything like that. But let's just say you needed to just, have a long sentence or a series of words you had to pass through a bunch of stuff or print in a bunch of places or maybe even change up at different times. You can easily just create a variable here like this and then manipulate it however you want. So I'm going to hit save. Go back into the editor. I'm going to hit play, and now it's going to print the sentence, this is my C# tutorial. So there are other variables, but those are the main ones that are used, and we'll probably cover the others as we go along. So that's it for today. Thank you for watching. Like this video, subscribe to my channel, follow me on Facebook and Twitter, and support me on Patreon. All links are in the description below. See you next time.